In this topic, we are going to cover threading. Threads are just small units of work, and threads are usually contained in processes. And a process can have more than one thread. However, the threads share the memory and state of the process. Threading in Python is basically a way of telling your code to do more than one thing at once. And threads can be useful to improve speed by performing actions concurrently, or for a program to remain responsive to input while also performing some other action which may be blocking. With Python, each process has at least one thread known as the main thread, which is where we have been executing our scripts for the most part during this course. However, we aren't really constrained to this single main thread if we don't want to be. So let's implement some multi-threading using the threading module in Python. Let's start by importing threading and time, and from datetime importing datetime. We can save this, threading demo.py, execute this. And let's start by demonstrating threading by comparing sequential sleeping with concurrent sleeping. So let's first have a function here called sleeper. This takes an argument I, and we can say hello from D, and then we can sleep for I seconds, and then we can say goodbye from D. And now that we have this function, we can use it. So let's first start by printing out the current time. We can format this in an easier way for us to read. And print out the hours, the minutes, and the seconds. And now we'll call sleeper and we'll pass in 0 as an argument, copy and paste this and execute it. And here we can see some output. We can see we've printed out the current time. We've then entered the function. We've printed out hello. We've slept for 0 seconds. We've printed out goodbye. And then we've printed out the time. And so we can see from the execution time that we slept for 0 seconds. So let's also include the function for 1, 2, and 3. So now when we call the function, we should sleep for 1 second, then for 2 seconds, and then for 3 seconds. So let's execute this. And here we can see some output where this has taken around 6 seconds to execute. And this is because we are being blocked here by time.sleep each time that this function is being called. Before executing sleeper 3, we first have to execute sleeper 2. And before executing sleeper 2, we first have to execute sleeper 1. However, by using threading, we don't actually have to wait like this if we don't want to. So instead, we could say threading.thread target equals sleeper. So here we're creating a new thread using the threading module. We're specifying the target function, which is sleeper. We also want to specify an argument. So we'll specify 1. And then we also want to start this thread. We can copy and paste this. 0, 1, 2, 3. So now these executions are equivalent and we can execute this. And we can see that by using threading, our execution occurs much faster. And each time we run this, the output could be very different, since these parallel threads could be scheduled differently with each execution. But in general, using threading in this case will execute faster concurrently than if we waited in a single main thread due to the action which we are performing here. So we can run this a few times And we can see just how much faster this is using threading than our original blocking method. And if we don't want to execute with a concurrent start, we can also delay the execution of a thread using a timer. And a timer takes an array of arguments and a dictionary of keyword arguments. So we need to pass them in as an array. So for example, we could create new threading calls here using a timer. We can copy and paste this. And we can execute this. And here we can again see the difference in execution speeds when we are waiting with our timer before executing or starting our thread. And these are just examples to demonstrate how threading works, but they aren't really that useful. So let's do something a bit more useful instead. So for example, how could we print something to the screen and at the same time get input from the user? This is a bit tricky in Python because if we just use input, the program will busy wait, waiting for us to enter our input. And at the same time, it can't also be easily printing as well. So we can see that. Print hello, input, print world. And here we can see we've printed out hello, and now Python is waiting for our input before we can print out world. And we can solve this problem by using threads. So let's create a thread to help us with this task by first defining a function, input thread. We can also have a global variable for stop. Then we can set up an infinite loop while true. We can ask the user for input, should we stop? We can print out what the user says. User says, we can check whether the user has asked us to stop by typing in yes. If that is the case, we set stop to be true and we break out of our infinite loop. And so this thread enables the user to pass information. So now we also need a thread to print information. So we might call it an output thread. We can also use that global variable. We can have a counter. And while we're not stopping, we can print out the counter. We can increment the counter. And we can sleep for 1 second. And so now we have two threads which can communicate with each other using a simple global variable. One thread prints out a counter, increments by 1 and sleeps for a second, while the other thread is constantly asking the user for input. And if the user requests for the program to stop by typing in yes, then we should stop executing from both of our threads. So now we just need to be able to start both of these threads, because if we just try to call input thread and output thread here, we'll have the same problem that we saw earlier. So instead, these need to be started as threads. So thread 1, threading.thread, target is the input thread. We don't have any variables here. We can start it straight away. And similarly, we might want our second thread. Specify the target. And start it. And now we can execute this. And now we can see that our counter in this output thread is printing numbers to the screen and waiting for 1 second each time. However, at the same time, the program is asking the user for input. So while this is printing, we can type in ASD and press enter. And here we can see our output, user says ASD. We can type in 123, press enter. User says 123. So now, from within Python, we're using two separate threads in order to print to the screen and to also ask the user for input. And so if we type in yes now and press enter, we can see that execution stops as expected. And rather than hacking together global Boolean variables, the threading module also has built-in functionality to help implement locking that can be used to synchronize threads. And locking can be used to control access to shared resources or to prevent corruption or deadlock issues with parallel processing, because the lock controls which thread is allowed to access a resource during execution. And in this lesson, we are only going to cover simple locking mechanisms. We won't talk about semaphores, reentrant locks, or the global interpreter lock. These are explained in more detail in the official threading documentation than what we can cover as part of this Python 201 for Hackers course. However, let's still demonstrate how to use a threading lock. So let's say we have some list and we want a number of threads to pop a value off of that list. Let's first comment this out. And let's create our lock, data_lock equals threading.lock. And now we can create our list that we want to pop values off. So data, this is our list, x for x in range, let's say 1000. And now we want to have a consumer thread. And let's first implement this without using a lock. So let's create a simple consumer thread, which can access that global data. And while there is something to remove, we can remove it. And now we can call this consume thread function by creating a few threads. So let's say threading.thread target equals consume thread. And we can start this straight away. And let's create 3 threads for this, and we can execute this. And we can see that our 3 threads have popped all of the data from this list. And if we execute this again, this will likely be in a different order due to how these are being scheduled by the operating system. But we may have accidentally introduced a race condition here, because we don't want multiple threads to pop the same value from the list by mistake. And to prevent this, we need to synchronize the threads, which we can do by using a locking mechanism. Once something is locked, we need to perform a blocking wait to acquire the lock. Then, once we are finished, we can release the lock and another thread can have a turn with it. And one of the main ideas of a threading lock is to prevent simultaneous modification of a variable. So a lock will force an operation to wait until the variable is unlocked in order to access and modify it. So let's change this function and also rename it to be a syncing consumer thread. We also want to have access to that data lock. We want to achieve the same outcome, which is removing all of the items from this list. However, we want to do that using a lock. So let's create an infinite loop here. Let's acquire the lock. And this is blocking, so you need to be careful not to introduce a deadlock here. Then we can check if the length is greater than 0. And if that's the case, we can pop it off. And then we can release the lock. And when this method is called, one of the waiting threads is allowed to take this lock. And so we can now execute this. Let's change this function name here. And we can see that now, when we're removing items from the list, this is happening in sequential order due to the locking mechanism. And we can also print out the thread's name here, threading.current thread.name, and execute this again. And here we can see each of the different threads popping values from this list. Something to be careful with when using threads is that when the main thread exits, it attempts to kill all of its child threads, unless the thread is specified as a daemon. Threading is a really useful tool when trying to perform multiple things at once and not wanting to wait or be blocked while processing occurs. We can even use the threading module to communicate and wait between thread completion using the join method, and depending on our implementation, we can also use threading to speed up processing, such as when performing brute forcing attacks. But that's it for now, and in the next lesson, we are going to cover PyCryptoDome.